Great. Okay, so I think it's live. Can you check if it
Yes, I'll check now.
Yeah.
I will say go ahead and start, and I will flag you down.
Okay. So, welcome to this talk about how to monitor the horrible solar quality using Elixir. First of all, disclaimer, I'm not an expert in embedded systems. This is a talk about embedded systems and how they converge with Elixir, being a functional programming language. And this project has been developed following a book called Build a Weather Station with Elixir and Nerves. So, first of all, about me a little bit. I'm a former researcher in high throughput distributed system fields. That means I work in things that are similar to Flink, Apache Flink these days. And I did that in a public university in Europe, which meant no pay at all. It wasn't fun, but I needed to eat, so I had to quit that. And then I decided to do a master's in data science. Not a really good idea, waste a lot of time, didn't learn much. And when I did this presentation, this was meant to be presented 2 months ago, but yeah, health issues appeared. And by then I was a lead software engineer at Onoma AI. It's a little startup here in Seoul working in building a product to make webtoons using AI. But I moved, and since this week I'm a junior backend engineer at remote.com, a company that basically allows other companies to hire internationally. So, table of contents. First, I'm going to introduce a little bit what's Elixir, why I use Elixir for embedded systems, and why other people use Elixir for Elixir systems, why I decided to build this weather station. Then I will give you a little introduction to Elixir, like why it was created and how it works. And then I will explain, like really briefly, how to build the weather station, but I will not go too much in detail. So Elixir is a dynamic functional language for building scalable and maintainable applications. This is like the definition that you can find in the official webpage. Then the first definition I heard at university was, it's better than Java. Well, anything is better than Java. Which was quite accurate when you have to do all your assignments in Java. And this is the definition that you can find in Korea. It's not much, but it's honest work, because there's no positions in Korea for Elixir as far as I know. The only ones that are offered is through my company, remote, because they hire all around the world, so you can work for them everywhere. Also, they are hiring, so if you are a mid-year or senior backend engineer in Elixir, you can apply. They're looking for people, so I encourage you to apply. So, why I decided to use Elixir for this project? First of all, because this is me using C or C++. Not a good experience, so I decided not to give it a try again. And the second option is Python, but it's too mainstream. And I did too much of that at work, so I was like, yeah, why not Elixir? So, now, why build a weather station? As I said, air quality here in Seoul is really bad. Now, mainly now in fall and in spring, like we have all this fine dust and also the yellow dust coming from the Gobi Desert in spring. And it can get really bad, and if you have any kind of respiratory problem, you can really put your life at risk if you open a window at home. And also, I live in a really old building, which means like the materials are not really good and they have bad elements in them, like organic volatile gases or something like that they are called. Something like this, not this old. This is the oldest apartment that existed in Seoul. It's been already demolished recently, but the illustration is similar to that, where I live. So, now, why build a weather station? You have weather stations for 45,000 won. Not too expensive, they give you all the information you need. You get them delivered the next day, so there's not much you have to do, just pay with your credit card. But I need a weather station, so made one for twice the cost and triple the time. So now, I'm going to explain to you why Elixir exists. Elixir does not exist by itself. it depends on Erlang. So back in the early 20th century, when the telephone came, 19th century actually, telephone arrived, and this is how telephone worked. You had ladies in rooms, like routing your calls from one place to another. With the arrival of the transistor and electronics, this changed, and this is now how routing looks. Now, these machines need software, and the biggest company in the world for this kind of machines is called Ericsson. It's a Swedish company, and in the 80s, 90s, they had an internal project, so all the software was built in C and C++, but the problem with C and C++ is core dumps, and if something fails, you need to spawn up again all the machines, and it was a big problem, because you cannot have a phone that does not work. So they invented Erlang. Erlang is a massive concurrency based on messages language. It has the let it crash approach, so it does not have exceptions. What Erlang does is it crashes. When there's an error, it just stops working, but it responds instantly. So there's no downtime. And it works on a VM, so it's compiled in bytecode, and then the VM interprets the bytecode. And it's the first language ever to reach 9 nines in SLA, which means that Ericsson, by contract, grants that their machines are going to be running without any kind of disruption ever, because basically they can stop 3 seconds per year, which means they don't stop. Now, Erlang is a quite niche language. It's not really used. It's basically used by Ericsson and other companies that need really, really fast systems that are massively distributed. But there was a language that was used fairly enough 10 years ago called Rails. Most startups last decade used Rails when they started. It was pretty straightforward to set it up. And this guy was part of the Rails core team. His name is Jose Balim. He is from Brazil, and he's also the creator of Elixir. So he knew about Erlang, and he liked it. He liked Elixir. Not Elixir, sorry, Erlang. But he thought that Erlang didn't look well. It was not friendly enough for modern developers. So he created Elixir, which compiles to the Erlang VM. It's heavily inspired by Rails syntax. So if you know Rails, you will see that there are many things in Elixir that look exactly like Rails. And of course, because it runs over the Erlang VM, it's fully compatible with all Erlang libraries. And it's functional. It's a functional programming language, which means it has first-order functions, it has pattern matching, all the cool stuff. This is a small example that you can read correctly. Fine, good. So yeah, anybody here doesn't know what's the difference between imperative or object-oriented language and functional language? Okay, so an imperative language, it's, as its name says, like you are really explicit about how do you want to execute your code. That's why you have loops and this kind of conditional statements. In a functional language, everything are functions, and functions can call other functions in a way that not like an imperative language that you can call a function inside another function, but pass functions as parameters. So as you can see here, for example, we have a function that is a first-order function that is takes 2 arguments and then an operation function, and it applies the function over the arguments, and then we have 3 different functions, like a plus, a minus, and a multiplication. And this will be the results and how you have to execute them on Elixir. I won't get into the notation, but well, Elixir as Rails works with modules. So you have to call the module. You can also alias the modules to avoid calling the module, and it has different ways to call functions. But yeah, this is how it works. Also, Elixir as Erlang has arity, so you can differentiate the different functions depending on the parameters. And this is the cool stuff about functional languages, which is pattern matching. So actually, this is code from this project. What this code does is to map information coming from one of the sensors in the weather station to a tuple for my API to process it and ingest it in the database. So as you can see, it has an anonymous function called reading that gets a parameter called reading, and it decomposes it. So it's a tuple that the first element is an atom called OK. An atom is like a constant, similar to what you will call a constant in other languages. And then you have another parameter that you don't know the shape. You just give it a value called measurement, and this is what it's going to do pattern matching against. So measurement can be anything. So what it does is, if anything has this shape, OK, comma, and then whatever it is, then it goes through, and it then maps it and take this information from this tuple. Well, this is a dictionary actually, seeing that it's a map. And otherwise, this is the otherwise operator. So in any other case, just return an empty dictionary. This is a link just to go for documentation about Elixir. If you want to check it, you can scan it with your phone. You also have the link. If you look Elixir Lang in Google, is the first link as well. And now, who's using Elixir? Well, I think the biggest company that everybody knows using Elixir is Discord. Discord is using Elixir for their messaging system. And not using Elixir, but using Erlang, WhatsApp. All the backend in WhatsApp is built in Erlang. That's also quite impressive. There are other companies, well, Remote also uses Elixir in the backend. And there's another company that makes systems for trains booking that use Elixir in Germany. So there are some companies that use Elixir, but it's still a quite niche language, so there's no big company using Elixir as their main language, as far as I know. Anyways, all big companies in the States, like Google, Facebook, all these big companies, they use Elixir in some internal projects as well, as far as I know. So now, how did I build the weather station? The hardware that is needed these days is quite expensive because of the scarcity in chips. But you can build this with fairly anything. So Arduino works, Raspberry works. I had one Raspberry 4 at home, so I decided to use my Raspberry. And then there's one company in the States called SparkFun. They basically take sensors, any kind of sensors you can think of, and assemble them in a plug-in way. So you don't have to be playing with electronics. You just have to plug and play. So these are the three sensors that compose this weather station. So this is just the hat, what is called the hat. It connects to the pins in the Raspberry. So I don't have to like assemble anything or do anything. It's just plug and play. And then we have an air quality sensor, a light sensor, another sensor that is an air quality sensor, but is more focused on gases than in CO2. Whoa, sorry. Now, this is built with one framework called Nerves. Nerves is a framework that is part of the official Elixir ecosystem. It's maintained by people that also maintains Elixir itself. And even though it's built 100% in Elixir, so you only interact with Elixir, behind the scenes, it has, of course, a lot of C and C++, and it allows hot loading of C and C++ libraries. So it's compatible. So it has built-in support for all these targets like Raspberry and other popular embedded systems. Also, they use 100% of Elixir is open source. And now I'm going to show you how this is built. So okay, no. So to interact with, I'm going to show you just one sensor. I built one sensor only. The other two sensors already someone prepared the library to interact with the sensors directly. So the idea of interacting with sensors is you have to talk with them. And to do this, there's one library in the nerve system called I2C. It's also a protocol. It's a standard protocol to talk with sensors, and you have to talk with them. So in Elixir, what we do is we create a server, which is similar to I don't know how to do an analogy in another language, but it's similar to the main, like, let's say like a pod in Kubernetes. So it's running, it runs the software, and if it crashes, it's spawned up again automatically by an orchestrator. In this case, is the virtual machine itself. So
the main thread.
yeah, it's like the main thread in a Kubernetes pod. And here we have the reconfiguration. So as we can see, the sensors, every sensor that you buy, it comes with a spreadsheet with the technical specifications. In that spreadsheet, you get the addresses in the sensors. So all sensors, they have a bus, and you can connect to different addresses in the bus to read different data. Now the problem is this data comes encoded, and you need to decode it in your target to know what it means. So for example, the VML sensor, which if I remember correctly is the light sensor, gives you different speeds when you want to read. So you can configure it like how fast it refreshes the information that is given. The faster it refreshes, the less accuracy. And you can also configure the gain. Again, the more gain, the less accuracy, but the fastest it updates. And depending on the configuration you have a factor to convert from the measure that it gives you to lumens, which is the measure that we use to actually measure the amount of light. And after configuring this, you can come and just have a little function in Elixir saying that the value that is configured in little endian 16 bits, and through I2C protocol, write read from the sensor in this address in address 4 in address 4, and read this value, which I don't remember what it does, but I guess it's another configuration parameter for the sensor to work. I don't remember because I did this like 3-4 months ago, so I forgot big part of it. I'm sorry. So when you have this working, you can go to I'm going to show you. Oh no. Oh no. Yeah, it killed the connection. So because of the network, it kills the connection.
Oh no, but it worked previously.
Yeah, but I think that's as soon as it.
What if you ping the device now?
Yeah, I think it's not configured to be connected through.
Yeah, but let's just, if you ping it, what address does it try to use?
Yeah. Yeah, the same. That's a problem. I will have to kill the.
Switch IP again though.
Hmm?
It switched the IP.
Yeah, it does. Well, I cannot connect.
Lame.
Yeah, I will have to stop the. I will have to stop the streaming for a moment at least.
Yeah, for a moment is fine.
Yeah, okay. Let's stop it. Okay, I'm sorry, but.
Can you use your hotspot or something, or do you use mine?
Problem with hotspot is connecting with the Raspberry.
Ah. Wait, why is that a problem? Can't you configure the Wi-Fi credentials on the Raspberry?
I can try. Okay, let's try. Now I can connect. Okay, now it works. Good.
And the stream is okay?
I don't know. Yeah. Okay, so now. Yeah, now I can connect. So this is the interface. This is actually the Raspberry is running nerves. It's well, it's basically an Erlang virtual machine with an interface to interact with it. And first of all, we can check if I have connection to the internet. I should, because I'm connected to Lunit Wi-Fi. Oh, wait, yeah, sorry. Okay, yeah, I do. Okay, nice, we have internet connection. Now, because this already has loaded everything, so what you have to do is to burn the, when you finish your project and you want to put the software. Of course, you cannot load in an embedded system. You cannot just run software as it is. So you have to burn it as a firmware. It's already burned. So the problem I have right now is this was burned months ago. With the last update in Macintosh, the OTP, which is the Erlang virtual machine, doesn't work with the GIT compiler for ARM. So I will have to recompile for the newer version, and I don't know if it's going to work because it's a totally new version. It's a jump from 25 to 26. Something's changed, and I don't know if it's going to break. So problem is I cannot change the IP to connect to the database without like burning the new version. So I'm going to show you first how this works, how the sensors work, and then I will try to burn, and if it works, it will be great because I will be able to show you on Grafana how to visualize this. If it doesn't work, I'm sorry. I will just show you like some data that is stored in my database from months ago, but I won't be able to show you in real time how this is working. So here, this is just an alias, it's preloaded to connect to the VML sensor, and we have one function which is get measurement, which gives us the lumens. So these are the lumens. If I check which one is it, yeah, it's this one. So this works in real time. As you see, it's pointing up. If I put my finger on top of it, it will go down to 4. The same happens with other sensors. For example, the SGP30, it gives us the address it has. Also, this is another thing. When you want to build a system with different sensors in the I2C, using the I2C standard, you have to make sure that those sensors use different addresses. If they don't, then you will need to get a multiplexer to be able to connect to the same address using different sensors, which is more difficult because it requires more configuration, and also you need to buy a device which is quite expensive because it's basically a hardware multiplexer to have access to the same address, to different buses using the same address on the same device, which is a little bit more tricky. But as you can see here, well, the air quality here is good. We have 0 volatile gases, 400 CO2, which is the minimum the sensor can measure. The sensitivity is that. This is the reference it has to A2C, and also like the raw values of ethanol and nitrogen. So yeah, I'm going to try now to connect to my phone directly. I don't know if this is going to work. Hopefully it will. If not, I will be locked out, and I will not be able to show you like the last part of the demo. Okay. 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 No. Yeah, it seems like it doesn't like it. Yeah. Yeah.
Wait, it's not the Pi is not connecting to your.
Yeah, to the phone.
So wait, why? When you connect to Lunit Wi-Fi.
Yeah, if I connect to Lunit Wi-Fi, it works. Oh, no, it doesn't either. Oh, now yes.
Oh.
The problem is probably Lunit has the network closed, so I will not be able to connect to my laptop on.
What's the device's IP?
Poof,
I want to test.
the public one, I don't know.
Well, public, private is fine.
Oh, 10. Oh, you use class A. Okay, 1010 144 24.
10,
144 24.
4, that should work. I can ping it.
You can ping it.
Yeah.
Okay.
So try SSHing into it. Well, once.
Oh no, you can it's not enabled. SSH through a network is not enabled.
I see.
I can try, but I didn't enable it, and I don't think it will work.
Before? Oh boy. Okay, cool. Me neither.
Okay, so let's see. Now, before I do this, let me check what's my IP here, so I can just configure it before I burn. Okay. Oh, this one. Oh, wait.
Sorry, could I ask you something?
Is this supposed to be my local IP here?
No.
No,
Wait,
right?
What network?
172. No, it should be 10, right?
What network are you on?
Lunit guest.
It should be 10.
Yeah, 10 10 1 4.
Double check mine too.
Yeah, it should be.
Wait, no. I need Windows actually.
Oh yeah, it's this one. It's this one.
Okay.
Okay, fine.
Thank you.
Now. Okay. Let's see if it works. Okay, we are compiling it. And burning. Oh, yes. Okay. I think I have to specify. I have to specify exactly how I want to burn it. So 1 second. Okay. I'm going to disconnect 1 second from.
We can pre-populate
Yeah.
lookup tables or whatever.
Yeah, exactly. You can pre-populate exactly. Yeah, this is more, of course, for development stuff. Now, the code itself lives in this folder in Live. When you have a Phoenix app, you have 2 different folders, which is the weather tracker, which contains all the logic for your server, like routes and whatnot, and then the weather track web, which is what is exposed to the outside.
So the service layer and the
Yeah. So here we have the router. The router is the one that defines the routes for your API, for example. So here in the scope API, with this module, pipe through API, and then we say we just have one function that is in, well, we define with a function post, which we define a post route in this endpoint, weather conditions, using this controller, this module, and the function create. So actually this atom will map to a function called create in the module. We can see it here. It doesn't navigate good. Is this the controller? No, this is the change set, so it's not this one. Nope. Oh, sorry. Yeah, here. So it's the controller. You have here this is the function, right?
Okay.
So we inspect the params coming. Then in case weather conditions create entry params, this function. Yeah. We receive the attributes. So we create an object with the shape of weather condition, which is the table that we define. And then create the change set and insert it into the data set. Repo is like a module that is defined by default with Ecto.
Okay.
So
it's like a Hibernate repository. It's just
yeah, exactly similar. So this is the repo. It uses Ecto repo. I didn't do anything, so I didn't define any kind of a specific logic because this is a really simple app. But here you can define like any logic that you need for your database to ingest, to consume data. You can define your queries. Everything would come here in the repo file.
So
Yeah.
because we seem to be okay on time, I just want to check people's understanding. Is anyone not familiar with no RM?
Or
Not familiar? Okay. Do you want to explain an ORM briefly?
Yeah,
and
sure.
Like what a repository is and that kind of stuff?
Yeah. So the traditional way, for example, to connect. Do you know Java?
yeah.
So the traditional way to connect to a database using Java is just use the JDBC driver, right? So when you connect directly with the JDBC driver, it works, but you have to handle yourself all data relationships. Like you have to make sure that you are not like allowing others to do attacks on using SQL injection or the other kind of SQL attacks, right? So an ORM, what it does is it grabs your JDBC or whatever driver you use, and it adds some functionality that makes easier for you to interact with your database. So what you do is you define schemas. So you define in Java, for example, you define objects that define the shape of your tables, right? And then you have a repository. I think in Hibernate it works like that, right? So you define a repository, which is a class in Java, where you have functions, public functions, that will call internally the JDBC, and will use the shapes that you have. So from your program point of view, you will be interacting with Java objects. And internally, Hibernate or whatever ORM in whatever language will transfer these objects or data structures into something that the database will understand.
You still have
And
some kind of load or save methods as well.
yeah, you can do whatever you want. So you can, for example, Ecto implements, so it's really similar to pure SQL language. So you can query SQL fairly similar as using SQL scripts.
So like, if without an ORM, you connect to your database and then you write SQL directly to do your database operations. With an ORM, it makes a bunch of assumptions and builds a bunch of stuff for you. So it's short for object relational models. So relational being like a database table, object being like an application object. So when, let's say he has like a temperature measurement as an object, right? And maybe there's a table for temperature measurement. He can just create his object in his code, say what attributes that object has, and then through migration, it can automatically create the database table. And then later, if he wants to add a new database measurement entry to that table, he just creates a new object, says save, and then it runs all the SQL for him.
So basically we are mirroring memory and storage, but in storage we have database.
Basically. Is that accurate?
Well, the database is the storage itself.
Yeah.
I mean,
Yeah.
you can have a layer in between. So in this repo, or wait, not this, here. In here, you can have anything in between. So at the same time that you are interacting with your database, you can have, I don't know, login systems, whatever you need. So it's really flexible. It depends a lot. So Ecto is extremely flexible. It's designed to be flexible. But other ORMs, they are more restrictive. So Hibernate, for example, makes too many assumptions, I think. So sometimes it makes things that you don't want it to make, and so it has ups and downs.
Other
Okay.
questions?
Okay, yeah.
Thank you.
So yeah, here we do the create entry, right? And then we do pattern matching. And we say, okay, so case, run this and do. In the case, we have a tuple that says okay, and this where condition equal to like an object that has this, well, a map that has this shape. Then log this that successfully created, and return through the connection a status created, which is 201 if I remember well, and a JSON containing the weather condition, which is the created entry, which has been pattern matched and assigned here.
So how does it identify that it's the create entry case?
Oh, I'm calling it. So case, so what it does is case, here I'm calling the function. So what the function returns is what is going to pattern match against.
I see.
If it fails, it will collect the error and will say fail to create. It will inspect the error, so I can.
Okay, so lines 15 and 21 are your pattern matching.
Yeah, exactly. So case is like to start the it's like the start of the pattern matching clause, and that's it. So it's really basic here. Yes.
The syntax is a little bit new for me, so
Mhm.
can I think about this like a Rust result?
Yeah, it's really similar to how Rust does pattern matching. Yes.
Okay, got it.
So for my own benefit and maybe for the benefit of others, I'm just going to walk through the logic real quick and correct me if I'm wrong at any point.
Mm-hmm.
So starting at line 14,
Yeah.
we're doing a case based on the result of this create entry function's output.
Mm-hmm.
Line 15, we're checking if the output of that function was A, okay,
Yeah.
and B, if the result matches this weather condition object.
Mm-hmm.
Okay, or not object, module, what do you call it? The weather.
It's a
condition
tuple.
change.
So this is a tuple.
Tuple, okay.
Yeah. So as you can see, so this is the documentation from Ecto.
Mhm.
So it says that it will return OK and struct if the struct has been successfully inserted, or error and the change set, which is the change set is a kind of data structure that Ecto uses for applying changes before putting them in the database.
Okay,
So it's like a middle step.
cool.
Also, it's used for granting data integrity and whatnot. It has a lot of functionalities.
Mhm.
If there was a validation or a known constraint error.
Okay,
So that's why we are pattern matching against the OK.
okay. So it's kind of like Golang, where Golang doesn't have errors, it has panics, but it often returns an error output, which you can check as true or false, right? Similar idea, except it's not a true or false, but it's which item is output.
Yeah, well, in this case, this function has only two different cases, but you can have 10,000. I don't know.
Cool. Thank you.
Sorry, can you explain a little bit better, not that you haven't done a good job already, what exactly OK
So
is doing? On the
yeah, so okay, anything that starts with like the semicolon
Yeah.
is an atom.
Why?
So atoms are constants that don't have a scope, they are global constants. So OK is here being used as a constant. So because this is a constant, we know that the shape of the tuple is going to be OK and something else. We don't care about what the something else is. It's here. We will call it a variable, right? So OK is basically like an anchor to make sure that this has been successfully created. So that's why we pattern match against it.
I think I
Otherwise, we are expecting an error. But you don't even have to expect the error. So I mean here, oh sorry. No. Yeah. Here I'm saying error. So this actually is going to have this shape. This will have this shape. Right?
Yeah.
So I'm just not matching it because I know it's going to be this. Now imagine that you have three different ones, right? Like you have OK, you have warning, and you have error. So what you could do here is instead of error, because if you just do pattern matching like this could be or warning or error, because you are not pattern matching against the whole shape of the object. So here you are just basically accepting anything.
Yeah.
So, kind of translate real quick, maybe?
Yeah.
So, like, items, what are they called in Ruby?
Atom.
Yeah.
Yeah.
So, I think the idea comes from Ruby.
Yeah, I think so. Yeah.
Yeah, where basically, like, you can think of it like an item as kind of like the way I think of it is like kind of a global variable almost.
Mhm.
And then the value is whatever that is, the colon whatever, right? So it kind of acts like both a variable and a value in and of itself. And it's just checking to see if this thing exists,
Yeah. Okay.
right? Maybe that doesn't
Yeah.
help, I don't know.
Just adding
Okay.
constants.
Let's see what the documentation
Yeah,
says.
because it could be colon
Yeah.
okay, it could be colon whatever.
Yeah, atoms are constants whose values are their own name. Yeah.
Atoms, not item. Okay, that makes more sense.
Atoms. Sorry. They are often useful for enumerate whatever. Yes. So yeah, basically they are constants. Their own name is their value, and they are never garbage collected.
And they could be character strings, numbers.
It has to
I
be
don't.
a valid variable name.
Yeah, I think not.
Convention.
I think not numbers actually, but we can check.
You can do column and then a string and then put whatever there.
Oh,
Just
God.
words.
Maybe.
Then quote.
No.
Aren't there any rules about it?
Yeah.
Like you
Oh.
Hedging.
Yeah.
Nobody does that. Don't do it.
Do you work with Elixir?
Yes.
Ah, okay, okay.
Don't do that.
But isn't that quote now part of the name?
Yeah, it is.
It is, right?
Yeah, yeah.
But it's not the number two. If you match that with number two,
Yeah.
it doesn't work. It's an atom, it's a different data type, has a different size in memory.
Is there no protocol whatsoever about the naming of atoms? Like it can literally be anything you like. Because I've seen some other languages
Try
that
a
like,
function.
don't use HTML element naming.
Is any string actually?
Like don't name it table, for example.
Yeah. That,
Yeah, you can name it whatever you want.
but
I mean, I think as long as it's not one of the items reserved for the Erlang standard libraries, I think you can use whatever you want.
Okay.
In that case, it would already exist.
Because I mean, you have these, right? So these ones, these 302, are like Erlang VM
So you can't name it
standard library basically. So you cannot call it array.
Well,
I mean, you can do, but it's not going to work. It's already defined.
all of them, you're not taking anything from anybody else. That's
they just exist or they don't exist.
yeah. The whole VM has visibility of them. So.
Oh, what? You can do dot? What?
Yeah, because so this comes from the so these atoms are mapped to the OTP, to the Erlang virtual machine.
So yeah, that one is a Erlang function.
Yeah.
Okay.
So they use atoms basically to make sure that you are not going to overwrite them. When you define an atom, it's not possible to overwrite it.
Gotcha. Now,
once defined.
Can you as a user do that? Can you define an atom as a function?
You can compile Erlang
Libraries,
way.
yeah.
Oh, you have to recompile.
Elixir moved away from this thing because Atom is in Erlang they don't have the dot. So any word without anything before it is an atom.
Okay.
So it's very hard even for me to read Erlang.
Mm-hmm.
Yeah, we never fall into this problem.
Okay.
It never happens.
Yeah.
Cool.
But the good thing is, because it's backwards compatible with Erlang, anything that is made in Erlang works directly in Elixir. You don't have to. It's like similar to what Scala does with the Java virtual machine.
But like, it's one of those things where Elixir was written to make Erlang easier, so you
Yeah.
probably just shouldn't do that.
So Elixir is Erlang with Ruby on Rails syntax, more or less.
Okay.
It's like, yeah.
Because I remember when I first learned about symbols, that's what they're called in Ruby. When I first learned about symbols, I was like, why would you, what, no, what does it, why? Okay.
Okay. And I think this is pretty much it. So the other thing is like this. So weather condition this is actually like the layer that maps your database to a data structure. So you can see here that you have allowed fields, which are the fields in the database. This is to encode it into the JSON. You have the schema weather conditions and these fields with these different data types. And then this is the change set, right? So the change set, as I explained it before, it's like a previous step before you apply any kind of operation to the database. And it can be used for many things. It can transform data. It's mainly used for transforming data and validating data. Making sure that also you have the relationships in place. So when your database is a real database, not this toy database, and you have like hundreds of relationships between different tables and joins that depend on each other, these change sets are used to make sure that before you do any kind of write in the database, those relationships are satisfied.
Okay. So question though. So when I hear change set, I think previous state to new state, right? And if the application doesn't know the previous state of the database until it makes a query, and then it can't guarantee that previous state unless it locks. Does Ecto do that or no?
I'm not sure. Do you know?
Optimistic.
Optimistic, right?
So if you mess things up and the transaction fails, you get a dirty transaction, and you get an error. It raises an error.
Yeah.
But it can validate anything in the input according to the rules you give to it. And when you're writing to the database, if you expect to write something based on an existing piece of data, as an engineer, you should know there is a race condition, right?
Right.
And sometimes it's fine.
Okay.
Yeah, you
Yeah.
make a choice. But yeah, we try to do a lot in the application because this scales horizontally, right? The database is usually too much, right? You can't scale that easily. So change set is a nice way to do that. Cool. While you wrap everything in a transaction.
Gotcha.
Yeah.
Okay, thank you.
I saw like in the company I'm working now, I saw transactions that are hundreds of lines. Yeah.
Okay.
So yeah, transactions can get really, really big as the complexity in your model increases.
Because I feel like the more transactions you're doing, the slower you're going to get, right? Because then the database becomes a bottleneck. But
Yeah, well, you can also, I mean, the change set is still not the database transaction. So the change set is a previous step. It still happens in your machine.
oh, okay. Okay, thank you.
So basically, this is like a validation step before you actually send the data to the database. Of course, if you're optimistic that it's going to work as he said, but the database can tell you, oh, this transaction is dirty, it doesn't work.
Got it.
So still, the database still does its own verifications, of course.
Gotcha.
At least SQL. No SQL, I don't know. Those databases are not real databases, so.
Don't say that to the wrong person.
So yeah, I think that's basically the project. I'm sorry I cannot really show you how it works in real time, but yeah, with this update to OTP 26 in Mac destroyed the whole project, and yeah, I think there are some internal APIs that change that Nerves depends on, So I will have to check. They just updated like a few weeks ago because of this. Yeah, who uses anything that is not Mac to develop, right? So that's the problem. Yeah.
So, a couple more questions then.
Yeah. Sorry.
So that Mix knows about Raspberry Pi and other
Yeah, about that, Mix doesn't know by default, but Nerves. I didn't show this part of the getting started, but Nerves basically expects one variable, environment variable.
Nerves is a library in Mix or Elixir.
Nerves is a framework built on Elixir. Mix is basically like the like the manager, task manager.
And then Mix and then Elixir.
Yeah, so Elixir is the language. Mix is built on top of Elixir. It's like the scripting environment of Elixir. And then Nerves is a framework that works on top of Elixir.
Or of Mix.
So what's your current
So-
ecosystem that you use the most?
Just Python.
Python. Okay. So
yeah.
Mix is pip.
Yeah,
Mix is Pip.
Yeah.
similar, yes.
Yeah.
Kind
Python
of.
is Elixir,
Mhm.
and then Nerves is like Django or something.
Mhm.
That's it.
Yeah.
Okay.
Yeah. Not exactly, because Nerves is not an API. Phoenix is that. It's more like some framework for interacting with.
Yeah, like you can think of Phoenix as Django, actually, because it has its own HTML thingy as well. It works fairly well.
So Nerves knows about Raspberry Pi and also other.
Yeah, exactly. So when you define this system environment variable, then when you compile the framework, it will look like Nerves will look for this variable. If it's not defined, it will fail. It will tell you like you have to define the target, because of course, depending on the hardware,
Yeah.
it will have to compile in different ways.
And it compiles not to bytecode but directly to machine code.
Yeah, exactly.
And you can also specify here like I want to program a smartware or something. Could work.
Mhm.
Yeah.
Yeah. Pitch. So.
I forgot, but that was interesting. Oh, your API interface, your input and output schemas.
Yeah.
How do you define that?
So in this case, I'm relying directly on Ecto. So Ecto by default
Okay.
provides schemas, right? So it's directly relying on it. So you can check here.
So, but normally is there a separation between the data model and the schema model?
You can define the separation.
Okay.
Yeah, it's flexible. So if you want the schema to be the same as the one that you define to interact with Ecto, with the database, you can use that one.
Okay.
If it's a different one, you can define an schema, and then on top of it, so there's one thing in Phoenix called views. So views are actually the schemas for the endpoints.
Okay, so very much MVC style.
Yeah.
Oh, right, because this is just custom code inside your create entry. You could do whatever.
Yeah.
Okay.
But you can create a view, and it can run another kind of checks.
Cool. What's mailer?
Hmm?
What's mailer?
This was in the code, but I don't. Something should.
Sends email.
Yeah, it's an email library. Yeah, I haven't used it. So this is like a Bootstrap Phoenix API.
Gotcha.
So I guess it comes by default.
So they set up the email thing as part of their API by default? Okay.
Yeah, maybe. I guess.
That's the data part. It's inside the application. The weather conditions folder is kind of like your application domain.
Yeah, exactly.
And then API is under weather tracker web.
Mhm.
And there in router you define. Like
Yeah, the routes. Yeah.
The endpoint takes. Well, you're not defining the parameters there, but
Mhm.
yeah, it just takes whatever you send.
Yeah.
Yeah, it works.
Yeah, I mean, for a toy project, it works. Yeah, of course. Like in a real app, you have to be way more careful. You need to process before you send anything inside your actual code. You process it and pattern match it as well.
You can choose to deploy them in separate machines. You can have like 100 machines running connected to the web, perhaps, like one connected to the database if you want.
So, oh yeah, that's another thing about Elixir. So Elixir is designed to work in a massive distributed system, like real distributed system, not just processes in the same computer, but different machines in the same network.
So it just handles inter-process communication for you?
Yeah. If you want, yes.
Yo, that's cool.
Which one? Elixir does it.
Yeah, well,
Point.
it's Erlang,
That's
yeah.
amazing.
Yeah, exactly. That's why it's used by these companies that need to process millions of messages per second.
Why does no one else do that? Holy shit.
I don't know.
Yeah, same question. Actually, many companies using Elixir, they are not doing things that require Elixir, and other companies that, I don't know, stock trading.
Yeah, that would be.
Yeah, the problem is, at the same time, Elixir is not crazy fast.
Oh, really?
Yeah, it's fast, but it's not as fast as C++,
Yeah.
of course,
Yeah.
because you have the VM in between.
Right.
So, but yeah, there are many cases like, I don't know, systems like Ticketmaster, ticketing systems, they could use this. They don't because they prefer just to crash and get their money anyways. They don't need it, they are monopoly, so yeah. Yeah. Some other question?
I had
Yeah.
one about the pattern matching part
Mm-hmm.
that you showed before. So if I don't remember wrongly, the documentation said that the second thing in your tuple, if I'm okay with the namings.
Here, you mean?
Yeah, this, yes.
Yes.
This was a struct. It said struct.
Yeah, these are structs, yes.
So would you?
You can think of it like a map or dictionary.
Right. So is it possible that you nest another pattern matching inside of here depending on the type that this struct is? Like in this case, of course, you're gonna get the weather condition, right? Because that's what you're creating.
I think not nest it directly, but what you can do is do pattern matching. So you can have okay and weather condition, or okay and another kind of, yeah.
But
You can
if
do it.
Oh, you can nest it as well?
Like, do you remember one variable inside weather condition? You can literally
Yeah.
write inside that.
Inside the.
Inside the parentheses.
Yeah, true. You can. Similar to like the 3 dots operator in JavaScript. Yeah, you can.
It goes as deep as you want.
But you have to define the exact shape to do that.
The
Yeah.
shape that you expect.
Yeah, exactly. You can. That you can do it. Yes.
Here you could have done like only okay and not okay, and then inside okay, weather condition or whatever else.
Yeah, if you're expecting different ones, then you could do. Yeah.
Okay, got it.
So in the single pattern matching, you could handle different cases of weather condition like
Right.
air quality above certain amount and have another condition without having to do nested conditions because you can just do a whole pattern with whatever depth of nesting. I'm not
Mhm.
explaining well at all. So weather condition, can we just take a peek at what properties there are or attributes?
Yeah. Will it allow me? Oh yes.
So
these
okay,
ones.
let's say CO2 level.
Yeah.
Right? So
This one.
we could, at that route layer, if I'm understanding correctly, we could, you have the validation to make sure that it's a valid success case where you get a weather condition result. But then
Mhm.
you could also do like, if the CO2 parts per million is beyond some amount, trigger some, and then have another condition.
Yeah.
Okay.
Yeah, you can.
All without having to do nested conditions.
Yeah,
That's cool.
you could do that. Yeah.
You can all pattern match to exact values, and then
Mhm.
you have something called guards.
Cards exactly. That is like an if.
Yes.
Yeah.
You can run a check on
Mhm.
values. You can't call an external function, but you can call any guard and
Yeah.
do.
Let me show you.
Or then you can check values on compile time. Set.
Oh, okay. This is
Interesting.
actually preview. So this is patterns. So in Elixir you don't.
Right?
Yeah. So in Elixir you cannot assign. So equal is not assign function. It's not an assign. An equal is a pattern match. So you pattern match the left operator to the right operator.
Wait, so what's the sign then?
Oh no, you don't assign. So it assigns, but it's difficult.
Function programming languages.
Yeah, it's functional exactly.
I keep trying to learn Haskell and I just end up crying.
Yeah,
in my
Haskell.
level of understanding of functional.
Haskell is difficult, but as you can see, you cannot do a pattern matching in something in the left that that cannot be assigned. That's why 2 equal to x doesn't work.
Oh.
It,
Oh, so
it will
equals
work.
can
It
be
will
equal.
work if x is equal to 2, but it's not.
Okay,
X
so-
like the last value of x is equal to 1. Now, look.
Okay. So equals can be either assignment or pattern match,
Mhm.
depending on context.
Yeah.
Okay.
Yeah. now, let me show you one thing. That's another thing. So the problem with this is, let's say that you do x equal 1, and now you want to check if x is equal to something, right? The problem is if you do this, you will assign x equal to 2,
Sure.
right?
That's fine.
That's why you have this operator, which is,
Fine.
I don't remember the name of the operator. It was,
Match or something?
yeah. So basically what it does is it implies that x is already assigned and you don't want to reassign it. So you want it to just do a matching.
Mm.
So it will say, no match.
Should have just made a different operator.
Yeah, design decision.
Double equal, like every language.
Yeah, you can also do double equal, yeah.
Okay. But then does double equal do proper pattern matching or does it do value matching?
It does comparison.
Comparison only,
Comparison,
yeah.
okay. It's a value matching.
It's
Yeah.
very easy.
Oh, the pin operator. Okay, pin operator, yes. As you can see, again, this is pattern matching operator, so it works as you want. You can have omit values.
Really should use a different symbol. Okay.
And the guards must be somewhere. Binaries, oh, here, yeah.
Okay.
Yeah, you see, when to true, to false.
But readability goes down.
Also, Elixir allows overloading of functions.
Oh boy. Yeah, that's what scared me about Ruby.
Well,
Why would you do this?
That's why you have /1/2 and so on.
well,
Oh,
no. That's the arity. That basically implies the amount of parameters that you are accepting in your function.
What are these different types parameters?
Yeah, so overloading of functions means that you can have. So
You can take his map and define it as a new.
you can have.
A good example is that like with the same name. But
Oh, I have to define a module, right?
That module, ASP,
Yeah.
do.
Yeah. Def module.
That's overloading. I think I don't know if it's overloading or overriding.
It's like hot
I
code
think you're
reloading.
overloading.
Oh, then no.
Hmm?
Sorry.
You're
Sorry,
doing
you're
hot
right.
code reloading. Like you can redefine a
Yeah,
module.
you're right.
Yeah.
And
So let's say that we have hello and okay, right? And this does IO puts okay.
Quotes.
Oh no.
and
Rip.
Yeah.
oh no, you need the close.
Yeah, it will.
You need the
It's
close.
not closing because your string is still going. This is why we don't program in the
Yeah, I know.
in the REPL.
Okay, and now.
But it's good for this example.
And now the hello. I don't know.
Error or whatever.
No, right? To IO. Right? So now if you come to hello and do hello, okay, it will pattern match to this one. If you do no, it will pattern match to this one, but if you do yes, it will tell you it does not exist. Cannot pattern match to anything.
Gotcha. Okay, so it has proper overloading.
Yeah.
Sorry, I thought you said overriding. I got confused.
So yeah, it's proper overloading, exactly. So you can do pattern matching on the function level, function definition level, because everything does pattern matching in Elixir, unless you specify otherwise. Yeah. Okay. Any other question?
What brought you to Elixir?
Oh, friends mainly. Yeah. Friends. So I knew about Elixir in 2017 is when I started. I think it's when it started becoming a little bit trendy because of Discord and some other products building on top of it. And I tried to get a job in Elixir. I did not succeed because I'm from Spain and there's only one big company that doing Elixir in Spain, Cabify. It's like Uber. Spanish Uber. And yeah, that was it. So I did some things with Elixir, but I just kind of stopped working with it because I had a real work to work on. And yeah, this summer I saw one offer from remote.com, and I applied to it while also doing this project because I wanted to build a weather station, and I was like, why not Elixir? And yeah, I got the job. So now I will be working with Elixir on a daily basis. Yay! So okay, we are going to wrap up then. I hope you enjoyed and learned a little bit about Elixir. I'm sorry that there are not jobs in Korea in Elixir. As far as I know, no one uses Elixir here. But again, there are companies that work on a remote basis. They hire internationally in general. And there are many cool companies out there, startups, using Elixir for different kind of problems. Elixir itself in the forum, it has a good board for job postings. Many of these startups are located in the States, and many of them ask you to work in States hours, so it's not really convenient living in Korea. But yeah, you can always give it a try. If you happen to be more experienced in Elixir, you can also apply to remote.com. They are hiring quite much right now. And yeah, in remote we work async. You can work whatever you want. We have unlimited paid time off, really nice. So so yeah, that's it. I hope you enjoyed the talk. Thank you.
Thank you, sir.